The focus of my research explores new techniques for debiasing language models, with a specific emphasis on fine-tuning GPT-2 small and GPT-2 large. As we know, despite their immense capabilities, large language models tend to perpetuate and amplify societal biases present in the training data. My work aims to counteract such biases through customized adaptation strategies. I utilize two key datasets in my experiments: the Wino bias dataset consisting of gender-balanced sentence pairs to construct an anti-stereotype dataset, and the StereoSet framework for evaluating gender bias in final model outputs. StereoSet provides an intra-sentence test which challenges models to complete fill-in-the-blank prompts in either stereotypical or anti-stereotypical ways. This allows granular analysis of bias alongside language modeling ability. The two key metrics reported are language modeling score to measure meaningful associations and stereotype score to measure bias frequency. The optimal values are 100 and 50 respectively. My methods involved conducting focused experiments on fine-tuning GPT-2, small and large, using the augmented anti-stereotype and neutrally masked datasets. To enable efficient adaptation, I employed three strategies: fine-tuning all layers, only the last layers, and using relative gradient norm to selectively update the most affected layers. The relative gradient norm was calculated as the ratio of gradient norm to parameter norm per layer, which gave insights into the learning dynamics and allowed faster fine-tuning. I also explored simpler in-context learning by prefixing the test prompts to indicate bias or provide counter-stereotypical examples. The results show fine-tuning GPT-2 small across all layers with anti-stereotype examples, significantly reduced gender bias with a stereotype score of 55 while achieving a high ICAT score of 81 and optimal balance. This configuration maintained a high language modeling score as well. In contrast, for GPT-2 large, fine-tuning with neutral masking better mitigated bias than anti-stereotypes, indicating increased adaptability in larger models. The relative impacts of in-context learning methods was more complex and prompt-dependent. In conclusion, this comprehensive study reveals the need for customized bias mitigation strategies based on model scale. While small models benefit more from anti-stereotype augmentation, neutral masking has greater impact in larger models. The complex interplay between factors like fine-tuning approach, model size, and end performance highlights the challenges in achieving both ethical alignment and strong language capabilities.